Today we're going to divide fractions. Now, there's many different types of numbers, mixed numbers, improper fractions, just fractions, and even whole numbers that we could divide by. So we are going to keep it real simple for 5th grade, and that is going to get extended upon in 6th grade. So today's more about, can we demonstrate, can we model it, and can we use it in a story problem? Can we figure this out in a story problem? So let's go ahead and try our first example. Piper used 1/5 of a meter and of ribbon to create a border around a triangle. If each side of the triangle has the same length, how much ribbon will Piper use for each side? So there's a hidden number there. So 1/5 of ribbon, so that's what we have total, right? I'm even going to mark that, okay, this is my total amount. And what are we separating it by? We're separating it for every single triangle side, right? So we have 1/5 meter of ribbon that is being divided. What's our hidden number? Triangle, got to remember sides of a triangle. And that would be, our hidden number is 3. So we're dividing it by 3. So we're going to be showing the area model, the number line, and then just mathematically what can I do with the numbers, and it's called inverse operation. So first with the area model, we are going to do the same thing that we did for like multiplication. What are we starting with? We're starting with 1/5. So if we're going to start with a fifth, we need to start with a whole. So let's make our whole and cut it into fifths. There's my fifths, and we need to show 1/5. There we go, that's what we're starting with. We're separating this, we're separating it into how many groups? 3. So it's gonna look just like multiplying, but it's quite different as far as the concept. So with multiplying, we would have chopped this up so we could find parts of the part. So we're going to read our area model a little bit differently. So I'm cutting this into, and I'm using dashes so you can see the difference. I'm cutting this into 3 groups. So this 1/5 is cut into 3. What is that representing? Well, the 3 was each side of the triangle, right? So there's 1 side, 2 sides, and then that 3rd side of the triangle, okay? So I can see what they started with because it's shaded, and then I can see what it was divided by because I can see those cuts, okay? And then we'll analyze in a second what we look at for our actual answer when we have all of our models done. Number line was quite similar to the area model is, what do we start with? We start with a fifth. So if we're going to start with a fifth, we need to have 1 whole. So we have 0 all the way to a whole, and what's making our whole is fifths. So we have to cut it into fifths. 1, 2, 3, 4, and then 5/5. Right? So this is the same thing as 5/5. So we can see where that 1/5 is at, right? And when we take these fifths, we're going to cut them into 3 pieces. So 1, 2, that's 4 pieces. So I need less cuts. Careful when you're counting your cuts versus counting your pieces. All right, now I have 3 pieces for my first fifth. So do you see how 1/5 is cut into 3, 2/5 is will be cut into 3, and we'll have all of our fifths cut into 3 pieces. So let's show that here, cutting all of them. You can see our 2 different amounts, just like you can with our area model. I can see our fraction that we started with, right, fifths, and then I can see what each fifth is being cut into. So here we can see our answer as well, and we'll talk about that in a second, but I am going to label for you that each of these is talking about a side. So there's side 1 for the triangle, here's side 2, and then here's side 3, what it's representing, how much that would be. So now for the inverse operation. You're going to like this. So if we have 1/5 divided by 3, what we can do is use what we've learned about inverse and take our 1/5 and not make it look like it's 6, and we can divide it by 3 by thinking about the inverse of that divided by 3. So we know that 1/5 would stay, and the inverse of dividing by 3 is multiplying by the fraction. So the inverse of the division and the inverse of the number. Now we have multiplying fractions. We're essentially taking a division of fractions and make it into a multiplication problem if we use the inverse method. And then we can just multiply straight across. So 1 times 1, 1. 5 times 3, 15. The answer is 1/15. Now, of course, we need a label, and then we'll talk about these models, is how much ribbon. Well, don't say ribbon. How is the ribbon being measured? And it's being measured by meters. So it's of a meter, or you could just say meter as well. Okay, so the big thing here for the inverse is switching that over to the inverse operation and inverse number. Okay, well, how is 1/15 being showed on this area model? Let's go back. So we had the 1/5 and then we cut it into 3. So each triangle is getting how much? That's one piece out of how much? 15. So you can see it's a 3 by 5. There is 1/15 being shown here. And then how is the number line showing 1/15? Well, each is getting 1 out of 15. So we have to look at all of our total cuts, and we have to look at how much each is getting in this particular situation because we're dividing by a whole number, right? Okay, so let's try this again. Looking at this example, Gemma makes 5 cups of pancake batter. She uses a scoop, which it's a 1/3 cup scoop to pour the batter into the skillet. How many pancakes can Gemma make? So, what's being divided? Gotta get this part right, otherwise our answer will be quite different. As you can see, our numbers are similar to what we just did in example 1. So if you think about the total, you'll always know what's being separated. What's the dividend? And this is our total. We're starting with 5 cups, and we're dividing it into groups of 1/3. So this time we're starting with a whole number, and we're dividing that whole number by a fraction. Let's see how our area model is different compared to our fraction. So we start with a fraction, we had to start with a whole to show that fraction, and then cut it that many times. So let's see, if we start with a whole, we need to show 5 wholes. Ooh, we need some space here. 1, 2, 3, 4, 5. I have 5 wholes. We always show what we're starting with. And I don't really need to shade anything because it's just what I have, right? And then what's happening to these 5 wholes? We're dividing it into thirds. So it's exactly what we're going to do with each of these wholes, and we're going to cut them into thirds. Now this is going to look a little bit different than how we did it with multiplication as well. So all of these are going to be cut into thirds. So a scoop, a scoop, a scoop, a scoop, a scoop, because every single one of these is worth a third, right? Because that's taking the 5 wholes and dividing it into groups of 1/3. So I have 1/3 groups out of all my wholes, and I can see them all, right? And what this represents is every single third is a pancake. So we'll come back to our answer in a second. Maybe you can even see it already. Let's go through all our models. So how would this be done on a number line? On a number line, same thing. What are we starting with? Now, when we had a fraction first versus a whole number, we had to represent that fraction and then cut it for how many times it's being divided. Okay, so what are we starting with? We're starting with 5 wholes. So we need to have a 0, and it needs to go all the way to 5. So we need a 1, a 2, a 3, and a 4 in there. Let's label those. Now, what's happening to each of these wholes? We have to represent the other number that's occurring, and we're cutting it into thirds. So it's interesting because when we divided this by wholes, they look like fractional pieces, right? That's where the inverse really comes into play. That if I chop a chunk up into 3, that's really 1 out of 3. So this one, it's a whole, and every single whole is going to be cut into thirds. Every single one of them. So I'm showing my 2 cuts that make the 3 pieces in between each whole. And again, right here, this chunk is showing that that's a pancake. Now, what's interesting about this answer is what would be logical, and we'll show this with the inverse. So let's take and see our problem again. And how would we do this for our inverse? So remember, we're doing the inverse of the operation. We're doing the inverse of the fraction. So 5 stays the same. Inverse of division is multiplication. The inverse of 1 over 3 is simply just 3. Now you could say, okay, I'm swapping them, so it's 3 over 1, but 3 over 1 is 3. So this is just a nice, easy whole number multiplication, and it's 15. So if it's 15, though, what are they talking about? What is our label? And then we'll talk about our models. 15 what? Pancakes. 15 pancakes. How can we see that in our models? Let's take a look. Let's work backwards. So if this is a pancake, for every single one of them, these are all pancakes. And there are how many of them? 15, right? 15 of those. And then if I count how many thirds I have, because that represents a pancake, that would be 15. See the difference? So you can really tell by what it's numbered by and then what it's cut by. So compared to our first one, we're taking a fifth. Now it looks like a whole, but in order to have the fifth, we had to have a whole, right? And then we had it cut into 3 pieces. So be careful, that looks like thirds, but it's really 3 pieces. Okay, so let's try these out. We're going to try all 3 methods here, and we are going to do the inverse, the area model, and the number line. Okay, so remind me, with the inverse, what do we do? 1/9, what are we going to change it to? Multiplication, and then if it's a 2, the inverse of 2 is a half. So we can multiply straight across now, and it's just a 1 over 18. That's our answer, 1 over 18. So what would this look like as an area model? If we have 1/9, okay, we have to start with that. So 1/9, all right, 9 pieces. Ugh. 1, 2, 3, 4, 5. Okay, so I have 6. I need 2 more. 7. No, more than that. 1, 2, 3, 4, 5, 6, 7, 8. I need 1 more. 9. Goodness. 9 pieces. And I need just 1 of them. So let's change just 1 of those 9s. And then what's happening to the 9s? It's getting cut. We're cutting it into 2 pieces. Chop, 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 chop. Okay, I have 1 piece, 2 pieces. So is it showing that this is 1 out of 18 pieces? Sure is. Now what about our number line? So again, if we started with a 1/9, we need to show this, and that would be starting with a whole. So we need to go all the way to 1 whole, which in this case, what makes a whole? 9/9, right? So, okay, we're gonna need 8 cuts then. 1, 2, 3, 4, 5, 6, 7, 8. Oh, that looks beautiful. It's rare that I can get them evenly spaced out nicely like that. So what's happening to the 1/9? All of the 9s, they're getting chopped into 2. So we need to represent that by cutting every single 9 into 2 pieces here, okay? And because we want to know what 1/9 cut into 2 is, we can see that this is 1 out of what makes a whole, now that we've cut it, 18, okay? Go ahead and maybe pause and try number 2. So it is flipped. It's a whole number divided by a 4th first. So pause and try this one, especially the inverse, and maybe even give the area model and number line a try. All right, so let's talk about the inverse here. Let's see how you did. Did you keep a 5? Did you multiply? Because that's the inverse of division. It's the inverse of 1/4. You should have said 4. That's a nice easy 20 then. Our answer is 20. Let's see how we can show that with an area model. So I am going to have to start with 5 holes. Ooh. Okay, let's go down here. 1, 2, moving down here. 3, 4, 5. Got it. The 5 is being cut into fourths. So I have to show that by chopping each of them into 4 pieces. And you might notice a pattern here based on what we're dividing by and what we always end up getting. So if I'm taking 5 and dividing it by fourths, how many of these pieces will I get? 20. Okay. So again, with the number line, we're going to start with what we're dividing, and we will have 0, and it needs to go all the way to 5. So we need, my 5s always look like 6. 1, 2, 3, 4. So 1, 2, 3, 4. What's happening to our 5 holes? We are dividing them into fourths. So each of these are going to be cut into 4 pieces. And every single piece represents the value. Now, did you notice? If I'm dividing a whole, what do I get? A whole number. If I'm dividing a fraction, what will I get? A fraction. It goes back to scaling with multiplication, that if I'm, depends what I'm dividing by and what answer I'll get. Let's see if that held true for these. Started with a, divided a whole, got a whole. Start with a fraction, got a fraction. I do see that pattern. Let's try one more. So this one's done for us with the model, but let's see if we can analyze it in both ways. There's a 1/6 of a birthday cake left over. If 3 friends share the remaining cake equally, what fraction of the entire cake will each friend receive? So what's being divided? The friends or the cake? Hopefully you said the cake. So we need to show that we understand that 1/6 is what's being divided by 3 people. So how is this showing it? So we have 1/6, and this is going to represent a person, one friend, right? And what is each friend going to get? Since we started with, we had 1/6, so see how this is a 0, and it's like this is a, goes all the way to a 6, or it goes to 6s, then you can, let me get that 0 out of the way, you can look and count what that is out of what makes a whole, okay? So if that's a whole, that's a 0, right? So this would be 1/6, 2/6, 3/6, 4/6, 5/6, and then of course it makes it a whole. And if we cut that into 3, how much is each person getting? All right, I see it. Do you? Maybe the inverse would help. So the inverse, we keep the 1/6 the same. The inverse is of the operation and what we're dividing by. So we're going to change that to multiplication. What is this going to change to? 1/3. Multiply straight across. Your answer is 1/18. So that is 1 out of 18 pieces. What's the label though? What fraction of the entire cake? So they're not giving us a specific like measurement of the 6, but we do know that this is of cake, right? It's not saying that this is a piece, so it's just of cake, okay? Sometimes the label can be funny like that. Now, as far as taking it further, 6th grade style, this is something that we're going to look at together in class, in person. So if you're watching this video because you are absent, then this is something we'll touch on when you return. If you are just reviewing, no need. This is not a 5th grade standard. Now, practicing, go for it. Let's see how you do. Don't forget the inverse, the area model, and the number lines, okay?